Hey guys, welcome back. We're going to be talking about the acid-base lab, lab 2, which is the buffer lab. Now I'm going to go ahead and just get to the buffer part, the lab part of this presentation. So this is about experiment 2 buffers. This is on pages 19 through 21 in the lab manual. And you have a summary in pre-lab, post-lab in the notebook. There is also an ALEKS for this, pretty sure. I'll have to verify the ALEKS stuff in a few minutes. Yeah, bear with me. So I will verify that. The things that you're going to be doing. So again, I will walk through in detail what has to happen for each of the different things that happen with the lab. But we're going to talk a little bit about how this relates to the materials that we've been talking about. So in the pre-lab, they ask you to set up the tables requested in the pre-lab section of the summary. That's A, B, and C. You're going to calculate the molarity of the sodium acetate prepared using 25 milliliters of acetic acid and 0.41 molar sodium acid, 0.410 grams of sodium acetate. The formula of sodium acetate is NaC2H3O2, not what is written in the lab manual. There is a typo in that. And you can use this, this link here. If you control click that link, that will take you to, wait, whoa, hold on, sorry. That should take you to this. So let me fix that. So control click that. That'll take you to this website right here. And this is Lentech. And you can type that, that formula in, the one that we have right here. Right there, and hit enter, and it will calculate that for you. I am assuming at this point that you know how to calculate molecular weights fairly easily. I am perfectly fine if you use these for anything that we do in the lecture portion. Do not use this for ALEKS because it will freak out about the number of decimal points that are here. That is not the same as what they are using in ALEKS, so make sure that you use the periodic tables in ALEKS for anything you do in ALEKS. But that's the molecular weight of that material. Okay, so that is the link that's there, and you can use that to calculate things. All right, you'll do 3 basic experiments. So you're going to set up to add HCl and NaOH to pure water to see what happens to the pH. So you're going to measure the pH, add HCl, measure the pH, add NaOH, see what happens. We're going to add HCl and NaOH to acetic acid to see what happens there. And then you're going to take the acetic acid, add some sodium acetate to it, and do the same thing. You're going to add HCl and NaOH to that to see what the effect is there. Okay, I would expect that you would see different things in pure water than you would in the acetic acid, and different things that you would see in the acetic acid and sodium acetate solution. Now, acetic acid and sodium acetate is a buffer, so I would expect there to be limited change in the pH from that. Now, from the data for that, before anything is added, you want to calculate the Ka of acetic acid based on the pH. So in that second thing that you're doing before you add the HCl and NaOH into the acetic acid, take the pH and use that to calculate Ka. We did a number of those calculations today in lecture. All right, so that's a different concentration solution. We did that earlier for a different concentration, so you'll need to do that calculation again, but it's set up the exact same way. You'll do the exact same thing for experiment 3, so the buffer solution, before HCl or NaOH is added to that, okay? You'll have your summary in pre-lab. Again, in your summary, the objective is on page 19. You make sure you've written that in your own words. Balanced chemical equation is right before the Ka expression on page 19. Ka is given in equation 1 on page 19. For 4a, use the pH to calculate the H plus using 10 to the negative pH. For B, set up an ice table, as we did in this lecture, to show the concentrations of each species at equilibrium. and the initial conditions, and then calculate the Ka. If you need help, please ask. I'm more than happy to walk you through this. And again, I will do a separate video on the lecture or the lab itself to walk you through some of those calculations. This is a general idea of what you're supposed to do. I'm hoping that you can try it with this, and then if you need the other, then you'll have it, okay? In 4C, you're going to do the same thing for the pH of the buffered solution. So in this case, we're using the pH from the buffered solution, figuring out what the equilibrium concentrations are, and then calculating Ka. For 4E, you need to look up the values for the Ka and give a source, okay? And for 4F, you want to calculate the percent error by using percent error is equal to the absolute value of the experimental value minus the accepted value over the accepted value. So the accepted value is the one that you look up. The experimental value is the one that you calculate, and you multiply that by 100. You're going to do that for both calculations or solutions 2 and 3. So the acetic acid by itself and then the acetic acid buffer, both of those calculations need to be done. On 5A, why would you expect that both of those solutions should give you the same value for Ka? So the one with it's just being acetic acid and the one with it being acetic acid in the buffer situation, I would expect those two numbers to be the same. Why? Why is it that that should be true? Okay. And then for 5B, you're going to use the equation of the reaction to show what effect the addition of the sodium acetate has on the equilibrium. So when you add that sodium acetate, does that equilibrium shift backwards, forwards, not move? What does it do? I want you to show me the equation, show what you're adding, i.e. point to the thing that you're changing in either up or down, and then show me the direction that it will shift, either forward or back. Okay. For 5C, the Ka should be the same in both cases. If it is, great. If not, what specifically could have been done wrong to make them not be the same? Now, I know that you didn't do this experiment yourself. I understand that. But you should have enough information to know what was done. The pH probe was put into that solution, some HCl and NaOH was added to it. What could possibly have gone wrong that might make those numbers different? So think about anything that might have happened, okay? For the post lab, you need to explain what Ka and Kb are and how they're related. We did talk about that today in lecture. On 2, explain why strong acids, HCl, and strong bases, NaOH, don't have K values. What happens when they're strong like that? So mathematically, why do those K values not exist? On 3, you need to write the dissociation reaction of HF and give a Ka expression for that dissociation. If the Ka is 6.6 times 10 to the minus 4th, we want you to set up an ICE table to show the calculation of pH. Okay, so either set it up with an ICE table or set it up using the Henderson-Hasselbalch equation. I don't care which one you do. Either one is fine. Those calculations should come out exactly the same. So either one is fine. Make sure that you list the equation for what you're doing so that I know which direction you're going. Be sure to show the equation before using it. And on D, explain why or why not the buffer is ideal. Why is it? Why is it not? What makes it ideal? So think about how we define ideality in a buffer solution. I'll give you a hint. Ideality in a buffer solution is when the two concentrations, the acid and the conjugate base, or the base and its conjugate acid, are equal. So if they're not equal, explain how different they are and how that might have an effect. Okay. For 3E, show the ICE table to determine the pH before the NaF was added. And then on 4, what makes it a buffer? A weak acid what? What's the formula, the thing that we're talking about? Okay, so they're asking you, what could you add to this to make a buffer solution? So think about what could you add to get the conjugate base in there? Okay, so what would the formula of the conjugate base be, and how would you get that in there? On 5, I want you to show the calculation for Ka using the Henderson-Hasselbalch equation, remembering that what it means to be an ideal buffer. If you have any questions about any of that, please let me know. And like I said, I will do a detailed explanation of the lab in just a few minutes. So you should be okay to do everything with the lab. This should at least get you started to be able to write some stuff down and start thinking about things. But I will do a detailed description of what needs to be done for the lab after the fact, okay? I'm going to stop sharing here, and I'm going to stop the recording, and I'll see you soon.